Per me non cambia niente, però... Okay, English. So, hey everybody, my name is Ju. I really love working with Ruby, and I work at a company in London which is called Alpha Sites. You can find me on Twitter. Nice job. You can find me on Twitter as Arkham. Last is a 4. Yeah, it was like someone took it. So yeah. Does anybody have read this book? Raise your hand. I repeat, does anybody have read this book? Raise your hand. Again? Okay, 10 people, that's pretty good. I read it for the first time, I think 2 years ago. Gotcha. I really liked it. And then a couple of months ago, I read it again. And I started thinking how the design principles that are explained in this book can or could be applied to software development. So I thought about giving this talk, which is called The Design of Everyday Ruby, just because I stole the title from this book. The author is called Donald Norman. He's founded a very famous consulting company, which is called Norman Nielsen. It's a very famous company in the usability field. I'll start with a nice thing first. There is another book which is constantly quoted by the design of everyday things, which is called The Catalog of Unfindable Objects by Carolman. And it should be, I think, a satirical book. So it should list objects which could not be found around. I think that if you look at this object under the hat of a software developer, you realize they're not as unfindable as they should be. So I just start with a few of them, not that much, unfortunately. The first one is a coffee pot for masochists. So I don't know about you, but many times I found myself in this position. You build something, then no, just you don't want to do it anymore. Or knife for pears. You have a very precise problem, and you build a very precise solution for it. Kangaroo rifle. Very good. Snow bicycle. So, usually you say just management made me do this, or whatever. But I think the last one is the one which really fits well software development, which is all-in-one. So it's kind of a Swiss knife, but it has everything. The book wasn't called The Design of Everyday Things initially. It was called The Psychology of Everyday Things. But then the author realized that this title wasn't selling, so he just changed the title. And it worked, because the book sold millions of copies. So that's another lesson. But it's called The Psychology originally, at least, because it teaches much more about how the human mind works rather than how to design things. So there's a lot of very good lessons in this book, but the one I think it's the greatest is you'll never be able to see a door in the same way. So usually when you're in front of a door, you just don't think about it, but after you've read this book, you won't be able to stop yourself from just thinking every time you're in front of any door, just like you're getting inside the bathroom or whatever. So if you see, this is the same door. I have 2 pictures. The message that this door sends, I think it's very clear. On the left, we have a plate for pushing. On the right, we have a handle for pulling. So this door speaks very, very clearly. Then we can find stuff like this. There's a handle just on one side, which could mean pull or twist. But then the label says push. So our brain goes, what the fuck, for a second. Then, okay, I'll just push, whatever. But it's kind of confusing, so I don't think it's the best. But then you can still find stuff that's worse, which is something like this. Turn handle up to open. What? No. So every time you're in front of a door, what happens? I don't know if I'm sure everybody of you has been on a train in Italy. And have you ever tried to open one of these doors between compartments. You never know if you have to push, you have to pull, you have to be careful not to kill someone who's coming from the other side. It's like, and every time you feel really stupid because you're there, maybe you have a degree in computer science or a PhD or, I don't know, I mean, you finished 2048? What's the game? I'm not sure. But you can't open a door. And the lesson that the book teaches you is that it's not your fault. It's not you that is stupid. You shouldn't blame yourself, but you should blame who designed the door, because they didn't even think about usability when they built it. Norman talks about mental models. So there are different mental models. If you think about the designer, usually the designer is given a problem. So he thinks about the problem. He thinks about a conceptual model of the problem, and then he tries to think of a solution to it. If he's lucky, then he can implement the solution and build an object and create an object. On the other hand, the user is just given an object. He can just take a look at it, tries to touch it somehow, tries to use it, and he can just build a mental model from these interactions with the object. So the designer model and the user model are like totally different things. They like have the same kind of name, but they don't relate ever. And the ugliest thing is that the designer cannot explain to the user how an object works. You can't be there because you already built the door. The door is there, and the user can just look at what you've built. You can't leave a note for. I mean, you can, but you shouldn't. Turn handle up to open. What Norman says is that design is an act of communication between the designer and the user, except that all the communication has to come from the device itself. So it's a very weird act of communication, because usually people just speak to each other, but in this situation, the designer cannot speak directly with the user. The only way he can speak to the user is through how the object looks, through how he designed the object. And the funny thing is that for the user, this thing is very, very easy to understand. You can just feel it if something is right or wrong. So a device which speaks clearly makes this difference. So I'm sure everybody of you will understand how to use this door. Very clear. It tells you one thing and does it right. Well, I think most of you will be confused to use a door like this. There's a handle, I think, for pushing, pulling, not sure. There's a sign which used to say, please use other door. And then someone pasted something and said, please use this door. You're like, what? And I think if you look at this door, it's kind of easy to make fun of it. But think about your code, or I can think about my code. I've done this millions of times. Just hack it in, and then it works, and fixed it. Go to the next card. So this has to do with you as well. Even if you're not a designer, you're not a front-end designer. I mean, maybe some of you is a designer as well, but most of you are Ruby developers, I guess. So, I mean, at least I can speak for myself. I don't really care that much about design in general, because that's not what I do on a day-to-day basis. But Dwight is not really buying it, because we spend our days reading, writing, and obsessing over software. So what if writing software is an act of communication as well? And you can't really speak with who will use the code, who will change the code, who will try to understand it. When we read software someone else has written, we're the users of the software. When we write software, we're the designers, obviously. When we hate software, we are angry users. I'm sure all of you will have had this experience. I don't know, Git, command line options. Are you kidding me? It's every time I have to Google the same thing. Open Google, Git, how to rename current branch. I cannot remember it for the life of me. Every time, I think for the past 3 months, the link has been violet for 3 months. And every time I Google the same thing, I click it, it's oh, it's git branch -m. That's so easy, I'm so dumb. But then you think that Git has so many different modes, and probably it's not my fault, I hope. So what I would try to do is to take the design principles that Norman enumerates and try to apply them to software writing. I won't really take all of them because I think some of those are well understood. I'll just take 4 of them. Visibility, affordances, constraints, and natural mappings. So let's start with the first one. Visibility. So a device function should always be visible. You should be able to take, I don't know, your object, your class, and immediately tell how it should be used. This does not mean that the device has to be easy, has to be simple. Far from it. If you think about your smartphone is a remarkable piece of hardware and software, but it's pretty easy to use. So the trick is to take less frequently used functions and hide them to reduce the apparent complexity of the device. So it should look easy to use, even if it's very complex. But at all times, it should be evident to the user what actions are available and how to perform them. So let's think about what this means. It means that whenever you're reading a class in your code base, you should be able to take a look at it, just like for 15 seconds, and have like a general understanding of what it does. I don't think this is something that happens often, I mean, at least in my experience. Another design principle which is kind of related is called affordances. And affordances are visual clues that suggest to the user how to use an object. So if you think about a suitcase has handles. And what Norman says is these handles kind of suggest the user, push the user to use the object using that kind of approach. So it kind of pushes the user in the right direction. If you think about doors, plates are for pushing and handles are for pulling. So you leave these kind of clues so that the user can find them later on. Okay, enough of the UI stuff. Let's see some code. No, wait, I'm just joking. Let's try with the screen test. Anybody of you knows what the screen test is? So basically, the trick is very simple. You have to squeeze your eyes to look like Asian people. Is it politically correct? I'm not sure. Okay, let's try to do this. Well, everybody of you squeeze your eyes. You have 10 seconds to understand what this class does, okay? Okay, time's up. Wasn't really 10 seconds, I know. I will just change a single thing in this class. You shouldn't really be able to see this code. That's the kind of the point of it. I'll just change a single thing, a single word in this code, which is this. So what does this word tells us about the whole class? It tells me two very important things. That the first 2 methods are the public interface of this class, and the last 3 methods are the implementation details of how this class does its thing. It's important that the public interface is kind of the same abstraction level. It doesn't delve too much into the details of how the class works. It just tells you, at higher level, what this does. So I have these matches with that's candidates.select. Candidate is anagram candidate. So it should be pretty much the same level of complexity you're expecting. You shouldn't be accessing data structures or stuff like that. So this simple change. 1 word. I think this is how we can implement code that is visible and offers affordances to the future users, be it ourselves or the new guy who just joined the team. So the trick is to use methods, public methods to make the API visible, and use private methods instead to hide implementation. And the trick is also try to keep the same kind of level of abstraction between the different things. Another design principle is constraints. They're kind of the other side of affordances. So if the affordances suggest the user how to use an object, a constraint limits the possible choices. So if you think about your digital camera, there is going to be usually a SD card slot. But you can't fit the SD card wrong. there's no way, because the guy who designed the digital camera made it like so that you cannot do it wrong. There's just one direction, like a bend, where you can fit the SD card. So that's a very good way of preventing people from using something in the wrong way. And so basically, the best way of making something easy to use is to restrict the possible choices. And if we want to kind of improve over this, I'd say that the best way of making something really easy to use is to make it impossible to use wrongly. You just offer it one way, and that way is right. You don't rely on the user to remember how to use the device correctly. As an example, I've ported these functions from another language. I won't disclose the language, so one manipulates strings, and the other manipulates arrays. They kind of do the same thing, because one is called strpos, so I think it kind of looks for something inside a string, and the other one is called inArray, which looks for something in an array. If you look about the order of the arguments, though, it's pretty funny, because first we have the thing we're searching in, which is the haystack. And the second argument is the needle, which is the thing we're searching for. This is the string module. If you think about your array module, it's the same but opposite. So the user which uses these functions has to remember the order of the arguments and use them in the right way. I know it's very fun to make fun of, very easy to make fun of PHP. Well, I said it. But if you think about your own code, I do this a lot of times. Sometimes it's just, I'm creating this service class, it just takes 2 arguments. And first is the author, and the second one is a blog post. And 2 days later, I create another class, which takes the blog post first, and then the author. It's I think it's really easy to make fun of PHP because this is in the standard library, so it shouldn't happen. But if you think about your own code, yeah, it's not that funny anymore, probably. So the trick here is in Ruby, it's extremely easy to make this class constrained. So you just need to use keyword arguments. You just the code hasn't changed much, in characters, some colons, I guess. But then the user can never use these functions in the wrong way. They always have to pass a haystack. They always have to pass needle. These arguments are defaulted. You can't use these methods in the wrong way. They're built in such a way that you can just use them in the right way. The last design principle I'll talk about is called natural mappings. And a natural mapping is, for me, very interesting because basically it's a very nice trick you can use, and it just works. You don't have to do pretty much anything. So you're building a natural mapping when your design takes advantage of a physical analogy or a cultural standard. You can think about when you're driving a car, the car transmission system is pretty complex. But if you want the car to turn left, you just turn the wheel to the left. And if you want to turn it right, you turn it to the right. So the mental model that the user builds is very simple. Just, if I go to the left, it goes to the left. If I go to the right, it goes to the right. It's very immediate. A cultural standard is something different. In Italy, we used to drive on the right, and in the UK, you drive on the left. So why? Well, just because someone one day woke up and okay, that's the way it is. But you would never want to violate this thing. I think in Malta, in the 60s, they've changed the driving direction, and for a week, it was accidents everywhere. People just making the mistake because they're so used to this cultural standard that they can't they're not thinking when they're using it, they just have it. So a natural mapping leads to a very clear conceptual model, and it's much easier to understand for the user. The other side of this is that if you ever find yourself in a situation where you need labels, diagrams, or instructions, it means you pretty much haven't got that real good natural mapping. It means you have to write push it's really hard for me even to think about it. You have to write push on a door which tells you to pull. So, I mean, it may work, but the users will always going to be very confused. Will be, yeah, I don't really know what to do. It's like, I'll just do this because it's just written there, but it just doesn't feel that good. So, if you take this active record class, we have a before save callback, which is geocode. And in the geocode class, we call geocoder, we pass the user, and we call process on it. There is a very interesting fact about active record before save callbacks, that if they ever return false, the chain will be halted, and active record won't save the object. So what you do is just you return true most of the times. But you don't want the new guy to just delete it, so you just add a comment. If geocoder returns false, it will hold the callback chain and Rails won't save. So I think this is very similar of like attaching a post-it to a door saying turn handle up to open. You're doing something which is not intuitive, does not like represent a physical analogy, does not represent a cultural standard, but you're just like, yeah, writing something, and then the guy will understand, I'm sure. He's not dumb. What I think we could do instead is make it like really evident, make it a cultural standard if there isn't one for this. So you could add to every active record object without halting save method, which just yields the retrieved block, returns true. So now in your code, you can just like, in all the before save callbacks, you don't want the return false to screw you. It's just to call without halting save, pass the block, call the logic that you need to call. And this like becomes a cultural standard after a while, because everybody will just know that if they need to do this, they will need to write without halting save. The other way is people just start copying and pasting this comment around in every active record callback. So, yeah. I mean, you don't even need to add all this like complexity. You can just like return a symbol here, which is without halting callback or something like that. With Ruby, we can do pretty much what we want. But the idea is just find a way of making it like evident. So comments should be your very last resort. I'm not saying you shouldn't use them because that's dumb. Like you fix a bug in the latest Rails, you want to write it down and like point to the PR which fixes it, hopefully. But usually in your everyday activity, every time you're about to write a comment, try to write a truthful method name instead, or try to just move around a bit stuff to make it more evident for the next guy. So what's the point of all these design principles? I mean, what's the final goal? Like, it is so hard like to keep track of all these like different things. So, like in my talk, I just want you to take only one point home, and this point is clarity. So, try to write your code and optimizing for understandability, for readability, for the next guy, for you in 3 months when you're home drunk, alone, trying to fix production code? Does this happen? That happens, yeah. Norman says, concentrate on one component, making things that are understandable and usable. So this guy, I mean, I would just like fill the whole talk with just his quotes because he's so good. I have like a man crush or something. So, yeah, whatever. But what I say is concentrate on one component, write software that is understandable and usable. So every time I have like different patterns or rules or methodologies that kind of clash, I just like this like guide me. I just want to make stuff that I will be able to read in 3 years and not just tell, oh my god, this guy was so dumb, and then run git blame like, oh, it's me. Cool. Yeah. Happens. So this is the first part of my talk. And the second part is going to be more controversial, I think. Not sure. So I'd like to reason a little bit about where instead we're going as an industry. It looks to me that as an industry, as Ruby developers in the Ruby ecosystem, we think we found the Holy Grail already. So if you want to be a pro, like a rockstar developer, you have to follow this precise set of rules. And they're very precise, and they're very well known, they're very widespread. Everybody of you, I'm sure, will have heard of them. So the first one is the love deliter. So Who knows? Let's do this. Probably be okay. No, raise your hand. Sorry. Do it. Love Demeter? Pretty good. Like people are kind of like nervous or scared to admit it, but they know it. And love Demeter. There are many definitions. The one I like the most is an object should just talk with his closest friends. You shouldn't talk to strangers or to friends' friends. So like LinkedIn or stuff like that. So you should just speak to your closest friends, and that's it. If we take these 3 active record classes, we have sport, a league which belongs to a sport, and a team which belongs to a league. So we have 3, like this is like something pretty typical in a Rails app. And then in the team, I want to reach out to the sport name because I want to show it in a sidebar or something like that. So what I do is I go into the league, I fetch the sport, and then I ask the sport its name. So this method violates the law of Demeter because we're asking something with its name to a friend's friend. So we should just be talking with our closest friends, which in this case is league, but we're not. We're kind of reaching outside our direct friendships. So the law of Demeter is broken here. What can we do to fix it is to add an intermediate method, which is sport name in the league class. So now the team just communicates with its closest friends, and the league communicates with its closest friends. So now what we have achieved is just basically we've inserted this separation, this isolation, this seam between these 2 classes, which kind of protects us from future changes or future possible changes. But if I put the hat of the software reader and then read this method, it's not as clear to me anymore. Because when I read this, I need to, in my editor, I need to open the league class, search for the def sport name function, and then look at the implementation. Which I guess it's what the law of Demeter like predicates. But from my point of view, is it worth it? Like, is this worse than this? I think this is really clear. It's like league, sport, name. Easy. If you don't need the level of, if you don't need the isolation, why should you put it in? Like, just because it's correct, it's the best practice? I don't know, it doesn't sound right to me. We can discuss about this later, I'm sure. I just leave this for 10 seconds as well. I'm sure everybody of you will have at least read like a small article from DHH, which is like, is TDD dead? Or something like that. Or TDD is dead, I'm not sure. And I've actually stolen pretty much of this code. So yeah, I mean, it's code from DHH. We use it daily, so it can't be bad. Well, I've changed it because I didn't like it, so whatever. I have a person class, which has an age. To calculate the age of a person, I take the year of today and I subtract the birthday year of the person. In order to test this, I can just create Jew, which is a person which was born in 1986. And I have to do something weird here, is to use timecop, which is this like external gem which like stubs date now, time, day to day, time now, etc. It's very like nice, I like it. So now that I've like basically freeze the time in 2014, I can then check the behavior of the code and see that Jews is 28 years old. Like from the pure testing perspective, this is not really good because we're kind of reaching out the outside world when we're trying to test our single class. So the trick taught by testers is just inject a dependency, right? So instead of like having the reference to day-to-day here, you just add a default argument for the age method, which defaults to day-to-day. And so the test is like much more elegant. You don't need to stop anything, you can just pass in the dependency. I've used TDD for a lot, and I love this. It's like it feels so good when you're doing something like this. Like, wow, look at this, I'm so good. This is so elegant. Yeah, it's like if I put the TDD hat, this is like perfect. If I put back again the software reader hat, I've inserted another level of indirection in my code. Now when I read this, I have to understand that now is not actually, doesn't mean anything. It's just defaulted to day-to-day. And actually from how the code should be used, it doesn't really mean anything that we have to pass a now, because now shouldn't change, right? I mean, if we're doing it, if you have like these different concepts of now in the same application, that's pretty fucked up as well. So we shouldn't do this. But we do this in name of pure testing. And we think it's very good because the test is very clear and it's very, like, input and outputs are very good. But I think from a just readability point of view, this thing suffers. And this is just 3 lines of code. If you, like, later we can talk more about this. Another common example that I found myself in is when I have an author, which has many posts, and I have an author presenter, which inherits from this shared implementation of a presenter pattern. And here I'm defining posts previews, which takes all the previews of all posts. So when I want to test this, yeah, I can do this. It's like I'm creating a post, I'm creating a fake object, which is Jew, which just exposes a single method, which is posts, and it returns an array where the single item is post. And then I create the presenter. And then I can test that presenter.postPreviews is equal to I love Ruby. And this is really fast and isolated. I'm not hitting the database at any level, so it just runs in 10 milliseconds. But the day I want to change the presenter to filter all the published posts and order them by latest first, what happens to my pure test? What can I do? I just change this fake object to nest more doubles. So I have a double which returns post, which returns in turn publish, which returns latest first, and then returns the post. In this way, the code is still very, the test is really fast. It still passes against the new implementation. But if I read this test and I read this, what is the actual meaning of this thing? I'm not sure. Like when I read a test like this, it doesn't really mean anything to me. It's like, what? Why would you ever do this? It's just, oh, okay, because you want to make this test fast and make it pass anyway. Okay, but yeah, I'm not sure. I think the most dangerous rule is actually dry. It's like, don't repeat yourself. I've seen so many premature, extractions, premature abstractions. It's just like, you think that these two things are the same thing, but after 30 minutes you realize they're kind of different. They're not really the same thing. And you just extracted them and you're just like, no, shit, I have to put them back again. If you take back the example from before about the person, I've added a new method, which is canDrink. And since we've decided to make it the dependency injectable, we have to pass the now here as well. And so to check if a person can drink, I'm passing a date, which defaults day to day, and then I check that age now is greater or equal than 21. Well, this doesn't apply to Italy, obviously, but it was the DHH example. So, if I want to improve this a step further, I noticed that day to day is duplicated here. So, if any line of code should just have one reason to change, I probably want to extract it to a private method, right? Okay, so now this passes the test. The tests are really nice, and the code is being dried up, so we don't have duplications. But I'm reading this code. It's kind of hard to read. And it's just 10 lines. Think about your 100 lines models or services. And think instead of having this, you can just have this. Can drink, age greater or equal than 21. It's I'm sure that there are some times which is worth it because it's very expensive to pass in some kind of global reference. But I wouldn't do it as a first thing because it's the best practice ever and I'm in love with it or anything like that. Because this is just much better. The last concept would be solid. So I'm sure most of you will be familiar with what solid is. It's a series of paradigms. I think that Uncle Bob wrote them in the 90s and 2000s. And they're single responsibility, open close, list of substitution principle, interface segregation, dependency inversion principle. And they're guidelines to how to build nice object-oriented code. If you apply all those patterns in Rails, you get to a structure of a Rails applications which is called hexagonal architecture. And this is an example from Jim Weirich, which is like was a great Ruby guru. So I have a controller, employees controller. There is a create method. I'm taking the params, create a new active record object, and then try to save it. If it succeeds, I go to the show path. If it fails, I render back the new. So this is like Rails, like 0.1, I think. I mean, it's just like Rails. Like if I think about Rails, I think about something like this. The bad thing, like if you think about it, is that Rails controllers do so many different things. It's not even funny. It's like they take params from HTTP. They call active record objects. They interact with them directly. Then they do either redirection, so they send like 3 HTTP codes, or they render templates and then return them back to the user. So like they're really like glue, basically. If I want to make this instead a hexagonal controller, what I can do is do something like this. Instead of the usual Rails controller, I'm creating a create runner, which takes the controller and then takes a new employee's repository. And then it runs against the params employee. Then I add 2 callbacks at the controller level, which is create succeeded, which is the happy path, the employees looks correctly saved. Create failed, unhappy path. Something went wrong, I have to render back the new again. And this is the controller. And then I have to build the create runner, which takes the controller and the repository. So I do it here. Create runner, the context is the controller, the repo is the repository. When someone calls run, passing the employee actions, I delegate the object creation and the object, like the fact that the object is being persisted to the repository. And then, depending from what the repository tells me back, I call the methods I've defined before in the controller. So create succeeded, created fail, and they're the same here. So this is actually the same thing. Like it just replicates the same exact functionality we had before. And we're still missing 2 classes. The first is the employees repository, which takes some arguments, builds an active record model, wraps it with the BIS. And BIS is what the domain logic, the business logic of the application resides, because active record should just be read-only object for some reason. And then when I save the employee, I just call it employee.save. So just delegate to active record the actual, like the employee being persisted. And then I have the BIS employee module, which like wraps employees. It's like simple delegator, so it just delegates stuff around, and then has like the custom logic. So we've added a freaking lot of complexity. There's like 4 levels of indirection, of delegation, of objects like talking with each other. And every step is very well isolated. But so I'm not saying like you should not do this, because I found myself there's places we want to do this, because otherwise it'd be impossible. But when you're doing this, you have to like realize and just like weight the benefits, because you're trading something like this for something like this. Like it's so small, like the projector can't even like print it out on the screen. And like when if I see like someone does this every time because it adheres to the hexagonal architecture pattern, this is pretty much my reaction. I found it really funny because this is an Italian politician. It's like all around the internet. It's like it's so good every time I see that lemma. So what I think is that if you follow all the rules all the time, what you get is this kind of designs. This should be like, I don't know, something. But there are so many different pieces which are kind of like indirect. And like I have a 2 here, I have a 2 here, I have a 2 here, I have a 2 here. So I think they're related somehow. I'm not sure how. So what I think when I use this pattern is I can use them if there's like the need to use them. But you shouldn't use them because someone told it's the right thing to do, because that's like just wrong. Like you're just like paying so much in advance for something you'll probably never use. So yeah. Instead, think about the trade-offs. There's in the series Is TDD Dead? Kent Beck says something really cool, which is every question in the whole computer science has the same answer, which is it depends. And he does these really nice like symbols, which means yeah, it's a trade-off. Like there's like these two different axes. And when you're thinking about applying a design pattern, a design methodology, a good practice, a best practice, I always think like, is this worth it? Like, and if I'm in doubt, the thing which helps me is like I think about clarity. It's like in 6 months, is this going to be readable or is it just going to be beautiful but not readable? What Norman says about doors is that that door is so like hard to use, and it's there because it must have won like a design contest. So like the door is there, nobody can use it, but it's there because it's beautiful. And sometimes I think we think that about our code as well. Like look at the code I've written, like 5 lines, it does everything. It's so clever, it's so elegant. But I'm not sure it's worth it. Like I'm just like concentrating on being like understandable, like, just like as a random act of kindness. So to wrap up everything, just close with this. Instead of solid, like give a try to aulic instead, which is avoid useless levels of indirection courageously. So aulic. Yeah. Okay, that's finished. I'm sure there will be questions. So I just want to take 30 seconds of your time, talk about the company I'm working on. We've been a startup for 8 years. Now we're profitable. And we have grown from 8 software developers, sorry, had to cough for a month, to 16 software developers in a year. And the team is split up between London and New York. We have 3 guys which are working remotely. We can try everything. We have 10% of our time which we can like use to do stuff, just like go places or read docs or work on your pet project. And so if you want to like come and talk to us, like, that'd be cool. And they paid for my flight here, so I guess I owe them. Yeah, so that's it. Question time. No, I'm not moving, so. No, I'm serious. Can somebody confirm from the organization that nobody will leave the room unless a question is being asked? Or even like you're a dickhead. Like. Yeah?
Good question. You talk about constraints related to the book, but then later you
should I go back to the class? Or?
No.
Okay.
You explain the hexagonal architecture, and I think that the hexagonal architecture is essentially a constraint. When I program, I always think, where do I put this? And I think the hexagonal architecture answers that most of the time. But instead of having blue code, I know exactly what I'm coding and what I'm putting in the base code.
Yeah, that's like I'm 100% with this. Sometimes it just feels to me that like a private memory controller could do the same thing. Like you could just, if it's like 3 lines of code, is it worth it to make a service?
Yeah, of course it is.
But the thing is, like, if you think that hexagonal architecture is the way to go, and if you're not doing it, you're a loser. I think like most of the feeling I get when reading articles is that like if you're not doing this, you're a fucking loser. You should like go and like die or something. It's like why? It's like there's like so much like complexity and abstraction you're just like putting in. It's like just wait a sec, just breathe, and then like see if it's worth it. If it's not, just like forget it. Okay, 2.
I was wondering, we all know that code we write is beautiful for us, but if supposing I'm your boss,
Mm.
and I'm telling you I don't care about how clear is your code for other
Mm.
developers,
Sure.
but I just care about you to deliver something
Mm.
in 2 days.
Sure.
What would you tell me?
Well,
About what you said,
Yeah, no,
the clarity of the code, the
yeah.
beautiful.
I think like if you see what happens to software projects when the general attitude is that after 3 years nobody can do anything anymore.
Yeah.
So I mean you can't really do anything. That's the what sucks about it. Like you have to find places where it's important for your boss. Like I won't like be like licking their asses, but when I'm working out, it's like my boss is the actual guy who wrote the whole platform. It's like a Rails app which is like gone through 8 years. And he knows that refactoring is important. He knows like that I'm doing this, I'm wasting 2 days of time because I want this to be understandable for the next poor guy. So he doesn't have to go through the same hell I went through. So, I mean, there's not much really what like you can do. You can just like show them like what happens if you don't do it. But like people are like if they're really fixed in their ideas, it doesn't really do anything. It's just like, yeah, whatever, blah, blah, blah. And like, just do it and like deliver. I mean, I think like if you don't really care, I mean, sometimes you don't even really care. You just like, friends of yours ask you, okay, somebody like left me this code, it's not working, can you fix it for me? And you just have like 30 minutes, just fix it, it works, fuck you, it's like, and ship it. But if you're doing it on something that you care about, which is, I don't know, your long-term project, your own project, or I don't know, your company's core business project, I don't think it's like clever, like in long term, but people don't understand it. Like either they understand it, either they don't, and from what I see, there's not much you can do. Oh shit. So yeah, sucks. Okay, 2 questions have been done, so you can go. Oh, we actually still have 10 minutes, right? Cool. So can we talk about something else? Just, no? Okay, cool. I call it a day.